RLC series. So today we'll cover series. Next week we cover parallel. So series sikit for today. Cost outcome and lesson outcome. Cost outcome means that for the cost, the outcome of the cost. Lesson outcome is the lesson for this topic, the outcome for this topic. So cost outcome number one, I believe you already the other lecturer already explained about cost outcome. We have two cost outcome. For the cost, for the cost we have CO1 and CO2, which is the ability to apply the circuit theorem and law to solve simple circuit. This is cost outcome number one. For cost outcome number two, the ability to analyze complex circuit by using analysis technique. So in this topic, hopefully after you finish this topic, everybody able to find the current, voltage, and power for of RLC series. So today's hopefully everybody can find the current, voltage, and power of the RLC series. So next week we will cover parallel circuit. And cost outcome number two, everybody able to apply the KVL, KCL, voltage divider rule, current divider rule to the RLC series. So we have two outcome for today course, two lesson outcome for today class. So everybody able to find current, voltage, and also able to use KVL and KCL. All right. So if you have any problem, just interrupt me. Just stop me. I will answer your problem. Now we start with what is RLC circuit. So RLC is come from R, resistor, R for resistor, L for inductor, and C for capacitor. So that circuit consists of a circuit consists of R, L, and C. So we can call that one is RLC circuit. For example, okay, we have resistor, inductor, and also capacitor. R, L, C. Resistor, inductor, and capacitor. This one we call series. Series. So R, L, and C is connected in series. For a parallel, so we have R, L, C. In a resistor, inductor, and capacitor in parallel. So we call this one is RLC parallel circuit. Okay. So application, there are a lot of applications such as oscillator circuit, radio receiver, and television also they use RLC for tuning. Tuning to select the frequency range. Okay, next is RLC circuit. RLC circuit can be used as a band pass filter, band stop filter, low pass filter, or high pass filter. This one is filter. We have filter to filter unnecessary frequency. Okay, now we start with RLC series. So as mentioned before, RLC series means that R, L, and C is R, L, and C connected in series. Okay, this one is R, L, and C connected in series. So R, L, C. Okay, for example, this circuit, we have a voltage source. Okay, look at this is AC signal. This symbol for AC, sine wave. For DC, the symbol is plus, minus, or this one, plus, minus. So plus minus is DC source. Okay, DC source. This one is AC. For AC is alternating current. So the current alternate positive cycle, negative cycle, positive cycle, negative cycle, positive cycle, negative cycle, positive cycle, negative cycle. Okay, that's what we call AC, alternate current. For DC, okay, just straight line. This is DC voltage, straight line. Okay, DC voltage or DC current, direct current. So DC, direct current. So the graph is just straight line. For AC, alternate. Okay. Okay, from this one, this one, until this one, we call one cycle. Half cycle, positive half cycle, negative half cycle. So full cycle. One cycle, one cycle. Two cycle. Okay, then we call two cycle. Okay. For DC, we have frequency. Does anyone know what is a frequency? What is frequency?
One over T.
1 over T. What is T?
Time.
Time to complete for one cycle. Okay. This is called one over this T. Time taken for one cycle. One cycle. So how many seconds? Time taken for one cycle, one complete cycle. This is half cycle and another half cycle. So one cycle time. Okay. Frequency known as how many cycle in 1 second. The unit is 1 over second, or second minus 1, or hertz. Okay, second minus 1. Okay, one cycle. How many cycle? For example, okay, this cycle, one cycle is equal to 1 second. Okay, for example, this one is one cycle, 1 second. For example, 1 second. So it means that frequency is equal to 1 hertz. Let's say we have 1,000 cycle. 1,000 cycle. 1,000 cycle. Oh, quite slow. Sorry. 1,000 cycle. The frequency 1,000 cycle. Time is just 1 second. 1 second. Okay, for example, we have 1,000 cycle in 1 second. So this, we call, this frequency is 1 kilohertz. Okay, 1 kilohertz. Any question? Any question? So frequency means that how many cycle in 1 second. If you have, for example, okay, for example, our internet, our Wi-Fi, we have 2.4 gig. Okay, gig means that billion. So this frequency, alternate frequency, yeah, 2.4 billion cycle, billion cycle in 1 second. 1 second only. Okay, this is called 2.4 gigahertz. So 2.4 billion cycle in 1 second. Okay, this one is we call frequency. Okay, frequency only exists for AC signal. For DC, there's no frequency. We can see that DC just straight line, so there's no frequency. Frequency for DC is equal to zero frequency. Okay, any question before we go to our topic? Okay, no question, huh? Good, very good. So no question. Okay, I believe you already learned about impedance. So this is we have resistor, inductor, and also capacitor. For resistor, we call resistance. For inductor, we call inductance. For capacitor, we call capacitance. Okay, the formula for inductance is equal to XL equal to J omega L, which is omega is equal to 2 pi F equal to J 2 pi F L. This is formula for inductance. For capacitance, the formula is equal to XC, XC equal to 1 over J omega C, which is equal to 1 over J 2 pi FC. Okay? This is capacitance and also inductance. So Z impedance is equal to R plus XL plus XC. So R, XL, XC. So impedance is equal to R plus, okay, XL, we have J, which is equal to R plus J 2 pi FL. This one, we can bring J to the up step, we call minus J over 2 pi FC. Okay, J, 1 over J is equal to minus J. So minus 2 pi (1 over 2 pi FC. Okay, this is impedance. Okay, that one is for voltage. Voltage. Okay, we go for impedance first. This one. Okay, no problem. Okay, any question in terms of impedance? So impedance, this is what we call impedance of the RLC series. Impedance. Z. No question, huh? No question. Okay, next we go for voltage. So we have voltage. This one is voltage source. Okay, current go in this direction. Okay, for series circuit, current here, this current, the current pass through voltage, the pass through resistance, the current pass through inductor, the current pass through capacitor is same, same current. Same current. Okay, current here same. All the current flow through this circuit, same current. Okay, this direction. Okay, in this, for resistor, the voltage is opposite the current flow. This is VR, VL, VC. Okay, the magnitude of voltage is opposite the flow of current. So this is the arrow of VR, VL, and VC. Okay, now we're using KVL, Kirchhoff voltage law. We can find the voltage around the current for this circuit. So, sorry. Okay, KVL here. KVL in this loop. Okay, we have minus VS plus VR plus VL plus VC equal to 0. Okay, KVL minus VS plus VC, plus VR plus VL plus VC equal to 0. Okay. Then we can rearrange it. We get Vs equal to VR plus VL plus VC. Okay. Voltage source is equal to voltage drop at resistor plus voltage drop at inductor plus voltage drop at capacitor. Okay. This one is voltage source. R, L, and C is load. So supply is equal to load. Okay, total supply is equal to total load. Total load is equal to VR plus VL plus VC. Okay. Okay. So in terms of J, okay, we know that capacitance, okay, inductance. So, okay, XL is equal to J omega L, XC is equal to minus J over omega C. Okay, minus j. Okay, what is j? What is j? What is j and what is minus a minus j? Okay, we know that real exists, imaginary exists. This one is real exists, imaginary. Okay, imaginary exists. J exists. So for resistor is in the real exists. So this is R, resistor, real exists. Okay, inductor, we have J. It's not okay, here. J 2 pi FL, J, means that positive J. Positive J, it will stay here, positive J. Imaginary exists. For capacitance, negative J. Negative J means that here, minus J. Okay? So far, okay ka? If you have a question, just let me know. Okay. So now, voltage, okay, voltage VL is here, VL. VC is here, and also VR is here. So triangle. So magnitude of VR is equal to, okay, so okay, voltage. Okay, this one is voltage. Voltage source is equal to VR plus VL plus VC. So where is VR? VR, okay, VR here. This is VL. This is VC. Okay. Okay, we know that VL and VC is opposite direction. So VL can be. Oh, no, this one. Vs is equal to plus J VL minus J VC. So we can VR plus J VL minus VC. Okay. This is Vs. So for magnitude, how to find the magnitude? Vs magnitude is equal to VR square plus VC VL minus VC square root. Okay, for example, this we have A triangle, B, C. So what is A? How to find A? Okay, A will be equal to B square plus C square root. Okay, trigonometry. Okay, when we relate in this form, we can say that B is VR. C is VL minus VC. Just we can substitute A is equal to Vs. So Vs equal to B is equal to VR square plus C VL minus VC squared. Okay. This is called magnitude of the voltage. Okay, this one, magnitude of the voltage. And then angle is here angle. Angle of the triangle. Theta equal to tangent C over B. Hello, any problem? This angle. Okay, okay. This angle. This angle, trigonometry, yeah? Trigonometry, this angle is equal to tangent theta is equal to C over B. So theta will be equal to inverse tangent C over B, which is C is equal to VL minus VC, B is equal to VR. Okay, so now we have this tangent angle. All right. Okay. Next is current. Okay, how to find the current? So current, we know that for Ohm's law, current is equal to voltage divided by impedance. So we have voltage is equal to this voltage. Impedance, we have our impedance. Okay, this one. Okay, Z is our impedance. Z is equal to, okay, from previous, okay, R, XL, XC. Okay, JXL minus JXC. So R will be equal to, Z will be equal to, Z equal to R plus JXL minus XC. So just repeat the previous formula. Magnitude for Z will be equal to R square plus XL minus XC square root. Okay. So you get this kind of magnitude. This is formula for magnitude of the impedance. And then the angle will be equal to tangent inverse XL minus XC divided by R. So we have impedance and also we have voltage. This one is voltage. So to find current, just take the formula for voltage. I will be equal to V theta divided by Z theta. Okay, I think that's all for voltage and current of the RLC series. Okay, any question regarding impedance, voltage, current of the RLC series circuit? Ada soalan tak? Okay, very good. So next is circuit power factor. Okay, what is power factor? The power of an AC is defined as the ratio active power to the total power. Yeah, active power. Okay. So we have active is power at the R. Power in R is called active power. Power at the resistor. Power in resistor. So for total power, power in Z, we have Z is equal to R plus JXL and XC. So total power is power in Z, in the total impedance. Okay. Now we can use the formula for active power is equal to I square R, and then the total power is I square Z. So R per Z, and then this is R per Z. Okay, cos phi. Okay, next is power consumed by resistor only. So inductor and capacitor does consume any power. Therefore, does not. Okay, I square R. Okay, next is current and voltage phase relation. Okay. Okay, in our circuit, let's say we have we have current, voltage. Let's say this is our voltage waveform. Voltage. Oops. Okay. Okay, for resistor, we know that the resistor is in, okay, let's say we have a previous graph on resistor in real. Imaginary exists, the real is resistor is here. So means that the resistor, the current for resistor and voltage is in same phase. This one is current. Voltage for current. Graph. Waveform of the current, red color. Waveform of the voltage, blue color. So that means in same phase. Look here. They cross at the same phase for resistor. For capacitor, we know that capacitor is in the imaginary axis, so J, XL. JSL means that the phase angle between J and R is 90 degree. This one is 90 degree. Okay, this is a form for voltage. Resistor, inductor, and also capacitor. Voltage, voltage, voltage. Okay, voltage waveform of the capacitor and inductor. Okay, for capacitor, we know that for inductor, we know that the capacitor, the inductor is L J 90 degree. So J 90 degree means that it will lag 90 degree here. This is current. Waveform of the current for capacitor, for inductor, 90 degree. Lag. The phase difference between voltage and current for inductor is 90 degree. You can see at this graph. This graph with voltage is here. So inductor will be 90 degree. J 90. For resistor is VR. This one is VL. So the difference is 90 degree. For capacitor, capacitor is at the bottom, J90. J, okay, minus J. Minus J, VC. So means that capacitor will be lagging, leading 90 degree. Current for capacitor, voltage, okay, this one is 90 degree. Okay. Next. Oh, this one is already explained before. Resonant. Okay, resonant. Okay, again, we have Z equal to R plus J omega L minus 1 over omega C. Okay, for resonant means that this part becomes 0, equal to 0. Okay, J part is 0. So how to get 0? We just equate it. Omega L is equal to 1 over omega C. 1 over omega C. Then you can get omega square equal to 1 over LC. Omega equal to square root 1 over LC. Okay. Omega is equal to 2 pi F. So 2 pi F equal to 1 over LC. F will be equal to F equal to 1 over 2 pi. Sorry. Okay, this one is frequency, resonant frequency. So at this frequency, our imaginary part will become 0. This is called resonant frequency. Okay, next is Q factor. Q factor is reactive power divided by active power. Reactive power is power at XL or XC. Reactive power is power at R. So power at resistor. So we can get XL over R or XL over XC. Oh, sorry, XC over R. Then key factor XL over R equal to SC over R. So we can get, finally we can get this formula for total power. Sorry, Q factor. Q factor for series resonance circuit. Okay. Next we have exercise. So exercise. First, calculate the impedance. Impedance is equal to Z. Z equal to R plus XL plus XC. I'll say, what is XL equal to? What's XL? So we have frequency is 50. SL is equal to J 2 pi FL, which is equal to J times 2 pi times F is 50. J 2 pi 50. L is equal to 0.08 Henry. So equal to, so XC is equal to 1 over J 2 pi FC, which is equal to 1 over J 2 pi 50. C is equal to 8 micro. It will be equal to, okay, this one. This one is equal to 25.12390. Okay. Now we can put here is 4 plus J mm, 25.12 minus 3 400 398, I think 398. Okay, Z. So magnitude of Z will be equal to Z magnitude equal to square root or square plus 25.12 minus 398 square. Okay, we get Z equal to 373 ohm. This is the magnitude, the impedance. Next is circuit current. Okay, current, we know that voltage is 240. So current will be equal to 240 divided by Z. Which is equal to 240 divided by 373 equal to 0.65 ampere. Okay. phase angle between voltage and current. Okay, phase angle between voltage and current. Okay, phase angle. Phase angle. This one. Tangent XL minus XC over R. Tangent phase angle is equal to tangent XL minus XC over R. Okay, XL minus XC is this value. Tangent 25.12 minus 398 over R is equal to 4. Okay. Minus 89 degree. Okay, next is power factor. So power factor, just take this value and cos it. Power factor is equal to cos angle. So we get cos 89 is equal to 0.001. Okay, next is power consumed. Just take the formula. Power consumed is equal to power consumed. Take the formula. VI cos angle, cos phi. VI cos phi power consumed. VI cos phi, which is equal to V is 240, I is 0.65, cos phi is 0.01. Okay, get this value. Power consumed in watt. Next is Q factor. Q factor just using the formula. This formula. Q factor. 1 over R, L over C. Q factor 1 over R square root L over C. Okay. Substitute the value. And we got this Q factor. Okay. I think that's all for RLC in series circuit. Okay, what you need to know is how to find the current, how to find the voltage, how to find the impedance, and power. Q factor. Power factor. Okay. So any question? Hello, any question? Just let me know.
No question, Doctor.
Wow, very good. Okay, if there is no question, so we can stop our lecture today. So we'll continue next week. RLC parallel circuit. Okay, thank you very much.
Doktor,
Yes,
next week is online or face to face?
kelas ke berapa? Petang?
8 pagi.
Itu elektronik kan?
Ha.
Oh iya, elektronik face to face next week.
Okay.
Kan nak online.
So we have lab next week.
Or next week, I think we will discuss. I will inform you. So we only have just one lab less. Lab number 3.
So we have just one lab, right?
Another one lab.
Okay, thank you, doctor.
Okay. All right. Okay, thank you very much.
Thank you, Doctor.
Thank you, Doctor. Bye, Doctor.